All right, so yesterday we had those steps that we wrote. I would like for you to write them down again, except for this time we will have the third step, which is to get your variables together, and then you'll solve that 1 or 2 step equation. I promise this is all the words you're going to have to write out, and then we just have a few examples to do. I'll make this a little bit bigger too. So. Now, whenever we solve equations, I will admit to you that you can do some of these steps out of order, and you may still get the right answer if you do everything correctly. However, I find that the best equation solvers follow these steps in this order. Because what a lot of students like to do is if they have like a +5, they like to move the +5 immediately because they see that it's like the easiest thing to deal with. So rather than following these steps, they do just whatever looks easiest to them first. And that doesn't always cause an error, but causes an error a lot of the time. So I would like to try my very best to persuade you to actually follow these steps each time. You pretty much always have to distribute first. You're not going to be able to get around that. You're going to have to do that. The step that a lot of students skip is the combining like terms. You really want to do that. Then a lot of students don't move their variables first. They move their numbers first, and it causes them trouble on a lot of questions. So we want to try to stick to this order each time. From my experience as a equation solver and teacher of equation solving, I'll tell you that it will help you if you go by these steps. So our first step is to distribute. Riley, do we have anything to distribute? What can we distribute? Good. What will that give me? Minus -42? Just minus 42. Good. Just minus 42. And then so we copy everything else down. -30 plus 2x. Alright. Next step. It says to combine like terms on each side. Now that's if it's possible. Can I combine 6x and -42? I cannot. Can I combine -30 and 2x? I cannot. So I'm skipping the second step because there is nothing to combine. I thought about it and was trying to, but I couldn't do it, right? All right, now, move your variables first. It makes you a better equation solver because some of you right now are wanting to add that 42. It's like sticking out to you like it's the easiest thing to do. Technically, it can be done that way. You might still get the same answer. But there are some problems where doing that will cause you to mess up. So, I want to move either the 6x or the 2x over to the other side so that I can get those x's together, because I can't solve for x. I can't get x by itself when there's more than one x. Right? I would prefer the 2x, because if I move the 2x, I avoid negatives. Plus, I really like having my x on the left-hand side also. So this is like best of both worlds. I would definitely move that 2x. So it is a plus 2x. When we're moving something to the other side, we have to use the opposite operation. So where it's a plus 2x, we got to do minus 2x. And so we would also do a minus 2x over here on that left-hand side. 6x minus 2x gives me 4x minus 42 equals 30. Negative 30, thank you. All right. So, Isabella, what should I do after that? Very good. We'll add the 42. We'll be left with 4x on that left-hand side. Isabella, what do I get whenever I do negative 30 plus 42? Positive 12. Very good. Ian, last step. Good. What do I get for my answer? Very good. Okay. Just a note here about checking. Some of you are like, never check my homework. But especially quizzes and tests, if you got some extra time at the end, it's a good idea. Whenever you plug it in the 3, make sure you plug it in for both of the x's. So you'll have negative 30 plus 2 times 3. So over here, you would get 6 times negative 4. Over here, you'd have negative 30 plus 6. 6 times negative 4 is negative 24. And negative 30 plus 6 is also negative 24. So since you get the same thing on both sides, that lets you know that you did it correctly. I'm not going to require you to check your work. I wouldn't even encourage you, like when you take your quiz tomorrow, to check your work on every problem after you finish it, because sometimes that will make you so slow that you don't finish on time. But if you finish before everyone else is done, or if there's still time left, it's a good idea, especially if there's any that you feel uncertain about, to go back and check those. Okay. All right, let's do another problem. Oh, this is a fun one. Alright, if I have not convinced you already to draw that line right there at the equal sign, the bigger the problem is, the better it is to have that line written, because that equal sign has to stay right there, and you don't want to move it to a different spot, which I see a lot of students do. Alright, Rosalind, what will we do first on this one? Distribute. Very good. Now, we got to distribute 1/3. 1/3 times 6. What's that going to give us, Rosalind? Very good. Which is 2. So I'll have 2x. And then I've got to do 1/3 times 9. Rosalind, what do I get when I do 1/3 times 9? Good. And what is 9 over 3? 3. So we get 2x plus 3 there. So really the fractions are gone now. Multiplying by 1/3, what's that the same as doing? If I multiply, dividing by 3, right? Mm-hmm. Yes, as long as the numerator is 1. Yep. Yep, so essentially all you're really doing there is 6 divided by 3, which gives you 2, 9 divided by 3, which gives you 3. So, you might be able to do that in your head. All right, so first step was to distribute. Anna Grace, what's the second step? Good. Do I have anything on this left-hand side that I can combine? Okay, what can I put together? What do I get when I combine those? 0. So really, these cancel each other out. Oh, excuse me. I just have a 3 right there. Okay. Blakely, what would I do next? Very good. That's going to give me -8 equals 3x. And Cameron, what's the last step? We'll divide by what? 3. And does that go evenly? It does not, so let's just leave our answer x equals -8 thirds. All right, questions on that one? All right, got 2 more for us to do. All right, on this one, I'm going to work out the problem. I might make a mistake on purpose. If you see me make a mistake, I need you to alert me that a mistake has been made as I do this. We okay here? What would you do? No, you don't do that first. No. This is okay. I've not made a mistake yet. Up. Okay, so right here, look at what happened right there. Look at what I did. Did I add 27 on both sides of the equation? No, I acted like I was adding 27 to both sides of the equation, but I really added 27 here and 27 here, which I cannot do, right? So I did that on purpose because I see kids do that all the time. If you are doing something to one side, you have to do it to the other, and that is not what I was doing there. All I need to do right here is combine my like terms right there. So 3 and -27 is -24. So -24 minus 9m, or if you wrote -9m minus 24, that equals -9m minus 24. All right. Is that good? Okay. M's go away completely. I have no variable left. If you have no variable left, you know your answer is either infinitely many solutions or no solution. Is the statement true? Does negative 24 equal negative 24?
Yes.
Yes. So this is infinitely many solutions. Now, I could have actually realized that it was infinitely many solutions right here. As soon as you realize that both sides of the equation are exactly the same, it's going to be infinitely many solutions. So like right here where I had negative 24 minus 9m and negative 9m minus 24, which if I just switch the order there, it's going to be the same. I could have known right there that it was infinitely many solutions. So as soon as you recognize that both sides are the same, you can write that. Okay? Questions? All right, last one. Let me give you a second to write the problem down before I start. I also might make some mistakes, so I wouldn't write everything I do down just right away. Okay, here. It's supposed to be a negative 5? That would be the negative gets distributed to both, so you're exactly right, Lana. That needs to be a negative 5 right there. Making mistakes here. Did I? 2x, and this is a minus 1x. So when you combine that, it'll give you a positive 1x. You can put the 1 in front of the x if you want, but you don't have to. Did I make a mistake? I didn't make a mistake, but I also went against my directions for what to move first, right? Because if I had just done it a different way, I'd be done already. This is making it longer, right? But technically it could be done this way. Okay? So what I've done right here, I see kids do this all the time. There's two bad things that happen. First of all, if you had just moved your x's first, you wouldn't have gotten yourself into this situation, right? Because if you, like what we should have done, x plus 3 equals 9 plus x. If I just subtract my x's right here, they cancel on both sides. 3 equals 9. No solution. That's the best way to do this. Don't do, any of the stuff I've done here. But let's say that you do this incorrectly. What I see students do a lot of times, notice right here how I had my equal sign nicely falling on that line the whole time. And I subtracted that x, and since I didn't want it to go all the way altogether, I just wrote an x. I can't do that, but students do that a lot because they just don't know what else to do, right? So if I did do it this way, though, look what happened to my equal sign. It jumped way over here, not on the line anymore. I just moved it, which I cannot do. So if I did do it this way, what is x minus x?
0.
It is 0, right? There's nothing left on that side. It cancels, so the number that represents nothing is 0. And then it also cancels here, and you get 0 equals 6. 0 equals 6 is also no solution. So it could be done this way, but I would prefer if you move those x's first, you'll get to the answer quicker. Okay, so if you stick to those steps, distribute, combine like terms, move your x's to get them together, and then solve the rest of the equation, that should help you make fewer errors for those. Okay? All right, so I've got